Very often you have a data frame that has missing values. Now let's look at this data frame with a summary df. And it shows on the bottom of each variable how many missing values there are. So here you have 30 missing values, here you have 30 missing values, and here you have 20 and 20. Now, if you want to know how many missing values there are, let's first inspect this quantity. So quantity has like numbers from 1 till 10, but the first ones are NA. Now please mind that this NA has a special value in R. So it's not considered a word, it's also not considered a number. So we can use specific functions that actually run for this variable. So we can call isNA, that actually tells me, it returns a logical vector of trues and falses. So this shows me there are trues and falses. So true meaning yes, it encountered an NA, and false means that it didn't encounter an NA. So you can run a table on this vector, and then you know how many NAs there are and how many are not missing. Now another function that's very important with the NAs is the na.omit. Now the na.omit can be done on one variable. So it means that what it returns is the vector without any NAs. So you see here they have like some additional information where they say like, okay, this is the NA action, meaning these are the numbers or the position in my vector that are removed, and this is what is performed, so they are removed. Yeah. Now if you do this on the entire data frame, you will just remove any row that has an NA. Yeah, so if we first look at, let's say there are a few rows, and then maybe only so gross income has no NAs. Okay, so here we have like an example where there is some NAs for quantity and all NAs for total. Now, maybe I will just for the sake of explanation, I'll add another one that has no missings. Now, if we then save this in a different data frame, we're going to perform the na.omit on the whole data frame. Now, if we do that, we just have 0 rows because it deleted like all the rows that has even one NA. Yeah, so also because of this total variable, all NAs are removed. All rows are removed. So let's do this again, but now without the NA, without the total. Now the only thing that is left, so let me rerun the X. So this is now the data frame that we put in, the na.omit function. And as you can see, only these rows contain no NA. So that is returned when you run the na.omit function. So be careful about this na.omit. So the NAs has another problem that it is not considered numbers. So if we now want to, for instance, sum all the values in X, we will get an A. Right? So let's make it more explicit, and we just sum the values of one variable. We will get an NA. So with the summing variable, so even though we find in X there are some values in quantity, it will still return an NA because it encountered an NA somewhere. So within the sum function, you have to tell what you will do with the NA. So a very often used argument is na.rm. rm stands for remove. So here it says you remove the NA, so this stands for T stands for true, and then you sum the values that are left. Yeah, so if you will calculate the mean, it will just calculate the mean on these values, removing the NAs. Now, of course, there is not always this na.rm is not always used. So for instance, with a correlation, let's say I want to calculate the correlation between X quantity and X gross income. If I would just do it like this, oh sorry, I will get an NA, because again there is some NA, some quantity. Now, if you would think that this would work the same way as we done before, I mean, it would be very useful, but no, that's not true, because there is no such argument. And the reason is that the correlation actually has the possibility to either use pairwise or complete observations. Yeah, so I will tell more about this in another video. So here you should not use na.rm is true, but use is complete.